record this for a minute. Here's a cost curve homework, and let's go ahead and we'll assign number 1 to Brian and number 2 to Hung and number 3 to Scott. And let's come back in just a minute and look at the answers. And as you guys work on these, like you can always ask questions if you happen to get stuck or you don't know how to begin. Okay. Yeah. So just to reiterate, so number 1 is the 232 because it's not changing with Q, and then for number 2, what did you get for the variable cost of producing 21 units?
I think like I got like 1,980 for number 2.
and how did you get it?
Yeah, I put 21 into like the Q and I do the equation of it and calculate.
Okay, but remember, you have to get rid of that part, right? Because this is the total cost. So remember, total cost is going to be equal to variable cost plus fixed cost. So you have to, if you just plug in Q here, you calculate the total cost, right?
Oh yes.
So to get the variable cost, you have to subtract off the fixed cost.
Okay, so like,
because this is just about variable cost. Does everybody see what I'm talking about? Does that make sense to you, Brian and Scott?
Yeah, when I saw that, just focus on the 49Q, because when you explained it in the lesson, you said that basically the y-intercept was fixed, so you only saw 49 times 21 for the variable.
Yeah. So 49 times 21. Okay, Hung?
Yeah, okay.
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 Sure. And and what about number 3, Scott? How are you doing?
I did delta cost over delta quantity. So I took the quantity, the cost of the 21st unit, just focusing on the variable cost, and I divided by the change in the quantity. So 1,029 minus 980 over 21 minus 20, so just 41 over $149.
Yeah. And so you can see, right? So for every unit that we're adding, I mean, so you could just take the derivative with respect to Q.
And Q disappears, right? Go to the 1.
Yeah, and then you just get 49. But the derivative with respect to Q, right? That's the definition of marginal cost, but it's also this idea of and this is one of the like big ideas in this section, is the relationship between marginal cost and variable cost. Is that marginal cost is closely related to variable cost. They're not the same. But if we think about the variable cost, like how much does it cost to produce a unit at a time? Here, every time, since we have this, constant marginal cost, every time we produce one more unit, whether it's the first unit or the 21st unit, our costs are going to go up by exactly $49. Does that make sense?
Mm-hmm.
So yeah, okay. Let's go ahead and work on the other ones. So we'll go the same order. Brian, why don't you work on number 4, and Scott, now you and Hung switch positions, so I'll have number 4 can be Brian, number 5 can be Scott, and number 6 can be Hung. Oh, now Hung switched again. So go ahead and put down your I'll let you guys remember which numbers you are, so I don't have to. So yeah, number 4 is Brian, number 5 is Scott, and number 6 is Hung. And if you guys put down your hands now and then put them up when you have 4, 5, and 6 done, then we'll go ahead and move through it, okay? All right, so Brian, number 4, average fixed cost. What do you got?
All right, I got 42.33, which I got by dividing 89 with 21 units to get the
Yeah.
average.
Yeah, it's just the definition of average fixed cost, which is fixed cost divided by the quantity you're producing. Okay. And good job. So number 5, consider a firm, blah, blah, blah. What's the average variable cost of producing 21 units? And
My headphones are acting up. I got 49 though, if you can hear me.
okay.
It's same thing as the marginal cost.
Okay, there you go. And in this case, that's true because the marginal cost is constant. And that's, you know, something to bear in the back of your mind, because you'll see pretty quickly we'll get to cases where the marginal cost is no longer constant, and then that will change. So, but the calculation, right, is a little different. We would go, if we're computing average variable cost, then we would compute total variable cost, which would be 49 times 21, right?
Mm.
And then we divide by 21 and we just get back 49. So good job. Good job. And Hung, what about number 6?
I think that I got 889.
Yeah, because we still have this fixed cost component, right? That doesn't change with Q. And there you go. Okay, good job. So let's go ahead and we'll do Brian number 7 and Scott number 8, and then Hung number 9. And go ahead and take your hands down and put them up when you're ready. Okay. So number 7, Brian, what'd you get?
All right, I got 513, and yeah, I solved it by just focusing on the ones that have Q, because that would be the variable cost, and I plugged in 9, and I ignored the fixed.
Yeah.
value.
So you just and you can do this, you know, a lot of different ways. You know, formally, again, you say total cost is fixed cost plus variable cost, and then you can just take total cost and compute it, and then subtract off the fixed costs. But in any case, that's just going to leave you with that bit right there, right? The stuff that has the Q's in it. So you plug in the 9, and then you square the 9 and multiply it by 5, and sure enough, you get the 513. So good job. What about what's the variable cost of producing 9 units? I'm trying to see, are these the same? Okay. So what did you get for that one, Scott?
Oh, now I'm not sure. I'm not sure if it's the same or if it's 57.
Okay, well, it looks to me that like these are exactly the same, right? And because Ignithium is random, but the only difference is the fixed cost component, right? The questions are worded identically and everything. So,
Okay, so it'd be the same, 513.
yeah. Okay.
Okay, good. I got worded there.
Well, me too. You have to be careful because some of the wording is just a little bit subtle, and things do change. So you know you have to think
you really got to read
about it.
into it.
Yeah, you have to read it carefully, that's for sure. So, and then because it's random, sometimes you'll end up coincidentally with stuff that's exactly the same. And you know, that's okay, but it's just the way it is. Okay, Hung, what about number 9? Average fixed cost.
Number 9, I think that I got 33.78.
Okay, and what did you do there?
Oh, I do by like set the Q to equal to 1, and I solve the equation first. Then I get the answer and I divide it to 9.
Okay, now why did you set the Q equal to 1? I think you wanted to set it to 0, right? Because you want to isolate this fixed cost component, 287, and then divide that by 9, right? Like we did before.
Okay, so like, yeah.
You see what I'm saying?
Oh, yeah.
Yeah. So you're a little bit off because you put a 1 in here instead of a 0. Okay.
Okay.
Okay. Okay. So, and gee, we're almost done, right? So we'll do these last 3, and the last one is the most challenging one. So I'll tell you what. So let's do number 10 together. We'll take our time here for a minute. Let's do number 10 together. So you all work on number 10 and put your hands down, and when you're done with number 10, put your hand up, and then we'll do that with 11 and 12, and we'll be done. We'll do them together. Okay, so for number 10, let's go ahead and I'll ask you first, Brian.
Number 10, I got 57.
57 for the average variable cost. And do you want to, do you agree, Scott and Hung, 57?
Yeah, I agree. 57.
Yes.
Yeah, and you want to explain how you got it, Brian?
So basically I focus on the variable cost, which would be 12Q plus 5Q squared. I plugged in 9 and then I divided by 9.
Yeah, okay, so yeah, that's right. Okay, so you computed the total variable cost first, and then you divide by Q, and
Yeah.
yeah, okay, good job. So number 11, you can all put down your hands and we'll all work on number 11 together. One of the things I'll point out is there's a bunch of different ways to solve this. You can use calculus, but you don't have to. So that's just a hint for you. So go ahead and put your hand up when you're done with that one. Cheating. So you said, so what answer did you get?
I got 29,473.5.
Well, let's see. You're off.
Oh no.
Right. So the problem is, so you said you used the integral, and there's no problem with that, but you have to be careful, right? Because you know, it's not just using the integral. You got to compute the integral correctly, and then you got to get the limits of the integration correct, because you know, doing the antiderivative is one thing, but what happens in econ a lot is that people are great at antiderivatives, but they can't figure out what we would call boundary conditions, like what are the limits that they should be applying to the integral. so they get their constants wrong and stuff like that. So that's kind of sad, but it's true. So okay, so this is supposed to teach you about the relationship between marginal cost and so I'll go ahead and I'll just copy this question, and then I'll show you all on the whiteboard. So I'm gonna stop sharing this for a minute, and I'll share here. Okay, so yeah, in fact, in grad school, and if like you take a math econ, it's not cheating. You know, we just teach the techniques different ways because we have students with different interests in math when we were at the intermediate level. So, but the integral is proper, and you know, all of us do that. It's just that not everybody is ready for that. So okay, here's the, and see if you follow along with me, Brian. I'll talk with you for a minute, and then we'll come back and we'll talk to Scott and Hung and see. Okay, so what I'm going to do is I'm going to graph the marginal cost. Okay, and you know, a lot of times when you see stuff in the class that seems a little bit mysterious, it ends up being this exact problem when it relates to computing like total surplus or other things that we'll be talking about later. There's one other thing that happens in the class that's kind of, you know, hidden and a little bit tricky, which I'll bring up when the time comes in a couple of weeks. But this is one of the ones where it's like, I can't quite figure this problem, and it very well could be this problem, this issue that's causing stuff to be a little bit mysterious. So our Q is going to be 21. I'll put that down here on the horizontal axis because it's of interest to us. So up here, I graphed the marginal cost, and I'm not really concerned because this is more of an illustration than an actual graph, that I have the slope right. But there's the marginal cost. It's going to be a ray out of the origin. Can you see that, Brian? That it's just a ray out of the origin. And then I'm going to go ahead and I'll go ahead and put that point there. Okay, so now you see that once I know how many units I'm producing, I have a specific point on the marginal cost curve. And it turns out that if you really understand what marginal cost is telling you, then this should be pretty intuitive, because marginal cost is telling you the cost of each and every individual unit. And so for instance, remember, marginal cost is how much more, or how much, and actually I think it's kind of intuitive and better for a lot of students. But you know, this is just the language of our discipline. We don't talk about additional cost, but we talk about marginal cost. But conceptually, they're very, very similar. So similar, in fact, that in any case where you're going to use marginal cost, if you think about additional cost, you'll almost never run into a problem, meaning that you know, be misstating something or be inaccurate in some way. So I encourage students to, you know, first just think of marginal cost as being additional cost. So see if you follow me, Ryan. So the additional cost of producing one unit is down here. The additional cost of producing the second unit's down there. The additional cost of producing the third unit is there. The additional cost of producing the fourth unit is there. You see what I'm doing? I'm referring to the marginal cost associated with each of those units, and that's the additional cost it's costing the business to produce that particular unit. Now, variable cost, by definition, is all of the costs, right, that are changing as we change our level of output. And so if we add up all of these additional costs together, we end up getting the area underneath the marginal cost curve, right?
Yeah.
Yeah. So yeah, the triangle that I've highlighted here. And so the relationship between marginal cost and variable cost is that variable cost is equal to the sum of the marginal costs. Does that make sense? We're just adding them all up together, and that's going to be this whole area. And so if you think about and I don't know if you did this or not, Scott, but the antiderivative of this portion, right, this marginal cost curve function, right, is I'll put it here, 1/2, right, times 49q squared, right? And we could check that, because if we take the derivative of this, we'll get 2 times 1/2, that'll disappear. The 49 will still be there. And then we drop the q by 1 on the exponent. We just get q, right?
Then we just add the fixed cost.
Well, no. Well, hold on a minute. Yeah, because what's the total cost? Because
I treat it like a variable cost right at the beginning. I didn't even think that was marginal.
So total cost
That's what I did.
is equal to fixed cost plus variable cost. This one equation is 90% of everything that's being tested in this chapter. The only other thing is, if you think about it, right, is that TC divided by Q, that's average total cost. And then that's going to be average fixed cost, which is going to be fixed cost divided by Q, plus average variable cost, which is going to be variable cost divided by Q. But these two equations are, you see how they're the same. It's just one is Q divided by the other. So it's that simple. And then there's this relationship. So yeah, that's the whole thing. And now if you think about it, if you were to this is exactly what we do when we compute this area, right? Compute the area is a triangle, and the height of the triangle is going to be the height of the marginal cost function, which in this case, and I'll try to put it in a different color, right? The height is going to be 49q, right? Whatever the q is. And then the base is going to be q. So this triangle, the area, right, of the triangle is, for any point on the horizontal axis, it's going to be the height of the marginal cost function, 49q, times q, which is the base, times 1/2, because it's a triangle, right? So, and I don't know if you remember or not, Scott, but the definition of the integral is the area under the function, right?
Yeah.
So the triangle area and this integral we computed over here, they're the same thing, right? So yeah, anyway, to finish up, we compute the variable cost, and the variable cost in this case is going to be, and you all have your calculators with you, so I'll let you do it. But let me see if I can get it to go on here. So it's going to be, I'll put the numbers in, is going to be equal to our variable cost, which is going to be 49 times 21 times 21 times 1/2. And so what do you all get for that?
I got 10,804.5.
Okay,
Yeah,
that
same.
sounds good to me. So then our total cost is our fixed cost plus our variable cost. So we just add 889 to that, and what do we get?
$11,693.5.
11,693.5. Okay, and I'm gonna go over here. and I'll grab the hint and I'll paste it here. Ta-da! I'm clapping for you guys. I don't know if you hear my clapper. It's a little bit of a golf clap, but that's okay. It's still a clap. Okay. Any questions? No. Okay. So I'm going to go ahead and stop sharing, and then I'll reshare one more time. And did you have any questions, Hung, or are you fine?
Yeah, I'm good with it.
Okay. Now, so this one is I mean, I don't think we'll solve this one today, but I'll give you all a hint, right? So from question 11, we know how to calculate total cost, right? So we could do the same thing to get the total cost, but we have to get it as a general formula, right? So the total cost is a general formula, right? So a general function of Q, and then we've got to take total cost as a function of Q and divide it by Q to get average total cost as a function of Q. Does that make sense? And then we have one more thing that we've got to do, and that is we've got to remember that average total cost is minimized where marginal cost intersects with average total cost. So once we have the average total cost formula, then we set it equal to the marginal cost formula and we solve for Q. And that will give us the answer. Does everybody understand?
The answer 29 then?
Well, I don't know. In this case, it's 7.62.
Okay, let me see.
And so if you didn't get that, then let's go ahead and stop sharing and share, and we'll go back to the whiteboard. But here, right, in this example, and I think we have the same numbers. Let me check really quickly. Oh no, we don't have the same numbers. Yeah, it's a different problem. But in this case, right? Yeah, so the numbers are changed. But we can use this for purpose of illustration, right? We're gonna find well, maybe I'll use a different whiteboard. So what we're looking for is find the Q where ATC, which should be a function of Q, is equal to MC, which is a function of Q. And the Q that solves that, I'll call this Q hat, right? So Q hat is the minimum of the ATC. And this is just a relationship that hopefully you all are familiar with from principles of micro or from watching the lectures, but that's just like, you know, there are a lot of different ways actually to get this, but they're kind of beyond the scope of the course. But what's not beyond the scope of the course is that you understand that average total cost is minimized where the marginal cost intersects the average total cost curve. So okay, and if after the exam you all want to talk about this question a little bit more and you want to do a couple of practices, I'm good with that. But for right now, I'm going to go ahead and